Right, here's a question. Write the chemical formula for the substance sodium sulfide. All right. Now, what is the chemical formula? The chemical formula is the exact relationship between the atoms or ions in a substance. Okay, so we need to get the exact relationship. It tells us exactly what's in the substance. That's not a very good E, is it? But anyway, first of all, we have to identify what we're looking at. So sodium is a metal. Sulfide, well, sulfur is a non-metal. Is ide. What is ide? Ide is how we name the ions of single atoms of non-metals. So sulfur is a non-metal ion. Okay, and it's the straightforward ion of sulfur. Okay, so we've got sodium sulfide. You have to be a bit careful with this because quite often in chemistry we don't see sulfide very often. We see a lot of sulfates and sulfites, but in this case it's just sulfide. Okay, so let's move on. So what we know now is that this is a metal, this is a non-metal. This means this is an ionic substance. Because they're metal and non-metal, the vast majority of metal non-metal compounds are ionic. This also means it forms huge crystal lattices, and that means billions and billions and billions of ions together, all joined together by electrostatic attraction. All right, makes it a good strong bond, and because there's bonding in all directions, the charge from an ion goes in every direction. They have high melting points and boiling points. You can dissolve them in water very often. Sometimes you can't. Very often you can. But they have high melting points and boiling points. Okay, so we've got sodium sulfide. We've identified ionic substance. Okay, that means we need the lowest whole number ratio of the ions in that big lattice. Obviously, we're not going to write down Na 25 billion and S 25 billion if it was 1-to-1 ratio, right? We would just write a 1-to-1 ratio. So it'd be just NaS. But let's see what it actually is. So the first thing you do in this task, step number 1, is to write down the chemical symbols of your two substances in this. So the chemical symbols of the two elements, so Na and S, right? So there we go. It's going to be this something, but we need a number here and we need a number here to represent the number of ions in the lowest whole number ratio of these substances, these ions in the compound. The next thing I'm going to do is I'm going to write the valency of these substances above them. Sodium and sulfur both have specific valencies, and those valencies are, this is taking the transition area of the table out in the middle, but this is on page 6 of the data book for National 5 Scotland exams, and this is group 1, group 2, group 3, group 4, group 5, group 6, group 7, and group 0. Now they call it group 0 in this case because group 0 has 0 valency, right? Nice and simple. Group 1 has 1 valency, group 2 has 2 valency. So what is valency? Valency is the number of electrons an atom needs to lose or gain in order to have the same electron configuration as the noble gas nearest it on the periodic table, right? Lithium will lose 1 electron to be like helium. Sodium will lose 1 electron to be like neon. Potassium will lose 1 electron to be like argon, right? And oxygen will gain 2 electrons to be like neon. Sulfur will gain 2 electrons to be like argon. I think we've answered our question. So the valency for sodium is 1, needs to lose 1 electron. And for sulfur, it is 2. It needs to gain 2 electrons. If you want to look at the valency, just remember what they are. It's 1, 2, 3, 4, 3, 2, 1, 0. Okay? Group 4 has 4. You count up to group 4 and you count down from group 4 once you go beyond it. Okay, so we've got a valency. Sodium is 1, sulfur is 2, right? So we'll write our valency above. Sodium is 1, sulfur is 2. Okay, now what we do is we do the crisscross, right? And what happens here is just a very, very simple thing. You take the number from one side and you put it on the other side, right? So now we've got Na2 and S1. Okay. Now what we do is we write out, well, first of all, we check our whole number ratio. 2-to-1 is okay. That's the lowest whole number ratio, right? But we don't write ones in chemical formulae. So what our final chemical formula for this stuff is Na2S. There you go. There's the chemical formula for sodium sulfide. We'll look at a more complicated one, and we'll look at some different kinds of ions in a future video. Thanks for watching. By the way, sorry about my hands. Like a good chemist, I was painting yesterday, and like a good chemist, I didn't put on the gloves until my hands were already covered in paint. Apologies for that. See you next time.